C program for GCD and LCM. So GCD stands for greatest common divisor, and the LCM is stand for least common multiple. So for first of all we are going to discuss here common divisor. What is meant by common divisor? Or first of all we are going to discuss the divisor. So what is the divisor here? So for example, if we take the number 12, then the divisors of 12 are here 1, 2, 3, 4 and 6, 12. So these are all divisors of 12. That if we divide this number to 12, then remainder is equal to 0. So what is common divisor? Common divisor. So for example, if we take an example of 12 and 18. So common divisor of 12 and 18 are 1, 2, 3, then 6. Okay. So these are the common divisors of 12 and 8. So the greatest. So what is GCD here? So the greatest among these common divisors. So what is the greatest here? If we see here, the 6 is what? The greatest among this common divisor. So GCD is equal to what? 6 here. So next, so what is common multiple here? Multiple. So first of all we are going to discuss the multiple. So what is multiple here? So if we example take here 2. So what are the multiples of 2? 2, then 4, 8, 6, 8, 10. These are all multiple of 2. So common multiple. So for example, if we take common multiple of 2 and 3, so the common multiples are 6, then 12, 18, then 24. These are all common multiples of, therefore least common multiple is equal to, what is the least common multiple here? Again you can see here the least common multiple is 6. So LCM is equal to what here? LCM is equal to 6. So now we are going to write a C program to find GCD and LCM of for any given two numbers. So first of all, as we know that the GCD into LCM is equal to A into B if A and B are the given number. For example, if we take here 6 and 8, A is equal to 6 and B is equal to 8. So what is here GCD? If we take all the common divisor here of 6 and 8, common divisors of 6 and 8, and they are 1, then 2, 1, 2, okay, 1 and 2. So what is your GCD? GCD is equal to 2. And if we take the all multiple, common multiple here, now if we 12 is not common multiple, again 18 is not common multiple, 24 is common multiple. 24 is what? Common multiple. So then next and so on, 48 is again common multiple. So here GCD LCM is equal to 24. So now if we multiply here GCD into LCM, okay, LCM, then it is equal to 2 into 24, which is equal to 48, and which is nothing but the A into B. So what is A into B? That is 6 into 8, which is equal to again what? 48. So we are going to use this logic to find LCM of A and B. So first of all we are going to find GCD, and then LCM is equal to what? LCM is equal to LCM is equal to S into B divided by GCD. If we use this formula, then we get the LCM of the given number. So how to find now to find a GCD, we are going to use here. So how to find GCD here? Again, suppose we enter here A is equal to 12 and B is equal to 18. So what is the the largest number is what? Largest number is 18. So we call numerator is equal to 18 and denominator is equal to what? 12. And we are going to make here one table. I'm going to make here one table. Say here numerator, denominator and remainder here. Remainder. So what is your numerator? Numerator is equal to 18, denominator is 12, and what is the remainder here? If we divide 18 by 12, the remainder is equal to what? Remainder is equal to what? 6. Again, next time we take denominator here and a remainder, that is we exchange the numerator is equal to denominator and denominator is equal to remainder. And if we divide it by again if we divide numerator by denominator, remainder is 0. So when we get a remainder is 0, our denominator is GCD. So what is your denominator is 6. So the GCD of 12 and 18 is equal to 6. So this logic we are going to use here. Take one more example. Suppose we are going to take one more example. Say here 8. Take one more example. Take A is equal to 12 and B is equal to 32 here. Okay. So now here again B is greater. So say numerator is equal to 32 and denominator is equal to, we always divide largest number by smallest number, 12. So if we create here table, so numerator, then denominator and remainder. So here in the first step, for the first step, 32 is the numerator and denominator is 12. Now if we divide 32 by 12, then 12 times 2 is what? 32 is equal to, if we divide 32 by 12, then 24. So it is equal to, remainder is equal to what? 8. Remainder is 8. Next time, in next step, we are going to write here 12 and here 8. So the here again if we divide 12 by 8, then remainder is equal to what? 4. Next time again we take here 8 and we are going to take here 4. Okay, so now if we divide this numerator by denominator, the remainder is equal to what? 0. So when we get 0, this denominator is our GCD. Okay, this number is our what? GCD. I am highlighting here. This number is what? Our GCD. So the last denominator is what? Our GCD. So here we are going to use this logic to find GCD. So what is your GCD? GCD of 12 and 32 is equal to what? 4. So in C program, what we are going to write here? So void main, say void main, then we enter two numbers, say integer a, b, then we require numerator, denominator, and then we require remainder. Okay, then we enter here scanf, say %d, and a and b, Now then we exchange, say here if a is greater than b, then the numerator is equal to a and denominator is equal to b. Else our numerator is equal to b and denominator is equal to what? A. Now next we are going to determine remainder here. What is the remainder here? Remainder is equal to numerator percentage, this percentage sign we use for to modulus sign. It determines the remainder when we divide numerator by denominator. And then we are going to use the while loop while remainder is not equal to 0. Then in that case, if remainder is not equal to 0, then we are going to write here numerator is equal to we exchange here denominator. See here what we okay, here for the first step this is a denominator, and for the next step 12 is what, a numerator. So I am writing numerator denominator, and denominator is equal to remainder, and remainder is equal to what, numerator per modulo denominator. And finally the when this condition is false, then we print GCD is equal to what, printf GCD is equal to percent d what, numerator denominator is what, our GCD. And finally LCM is equal to a star b divided by GCD. So for example if we take here, say a is equal to 12 and b is equal to 18. So a is 12. Now this condition 12 greater than 18, this condition is what, false. So so this false means what, here numerator is equal to what, 18, and denominator is equal to what, 12. Then in the next step here remainder is equal to, if we divide, remainder is equal to what, 6. Now remainder is not equal to 0 here, remainder is not equal to 0. So here the numerator is equal to what, denominator. So what is denominator, 12, and denominator is equal to what, 6. And what is remainder here, if we divide 12 by 6, it is 0. So now this condition is false, this condition is what, false. So here it print GCD is equal to denominator. So what is denominator, denominator is 6. So we get the output. Now if we enter the number like say a is equal to 5 and b is equal to 10. Okay, so here again okay, instead of this 5 and 10 I am writing a is 10 and b is 5. Okay, so here in the first case it is true, here numerator is equal to what, numerator is 10 and denominator is what, 5. So for this case I am going to change this color. Okay, so for the second case, for this input we get numerator is 10, denominator is 5. And if we find here remainder here, so what is remainder, remainder is equal to 10 modulo 5, which is equal to 0, and which is, now this condition is what, it cannot enter in while loop, because what, this condition is false. So directly it print GCD is equal to denominator. So what is denominator, denominator is what, denominator is 5, denominator is what, 5. So it print here, why denominator 5, because you can check here denominator is what, 5. So it print denominator is what, 5. So now we are going to run this program in C. So first of all we are going to include header file, include stdio.h, include new.h, void main. Then we require two variables, say integer a, b. Okay, then clear the previous output, then printf enter a is equal to first number. Okay, then scanf percent d and a. Next printf enter b, scanf percent d and b. Next, since we enter a and b, we are going to check which number is greater than, a is greater than, whether a is greater than b or b is greater than a. If a is greater than b, in that case define new variable here, say numerator numerator and denominator, and we require one more, that is remainder, and we require GCD also to store GCD, and LCM also to store LCM. So now if A is greater than B, in that case our numerator is equal to A, largest number, and denominator is equal to what? B. And okay, and else our numerator is equal to what? Numerator is equal to B, and denominator is equal to what? Denominator is equal to A. For example, now I am going to print this so you can understood. So I am write print here, print f numerator is equal to, I am going to print here, numerator is equal to percent d numerator, and denominator is equal to printf denominator is equal to percent d denominator. Okay, so we want denominator should be less than numerator, and say get ch, and if we close the main loop here, okay, now if you compile here, there is 0 error. Now if you run here, and if we enter A is 4 and B is 6, then numerator is 6, denominator okay, we want new line here, new line character. Now if we run, so if we enter here 6 and 8, 6 and B is 8. Now here B is greater than A, so numerator is 8 and denominator is what? 6. Now if we enter A is large, say 8 and 5, so the numerator is what? 8 and denominator is what? 5. So numerator always take largest value and denominator is what? Smallest value. Now I am going to delete this. So in the next step, once we decide our numerator and denominator, in the next step, if here remainder, we are going to find remainder is equal to numerator modulo denominator. Okay, and next while okay, for example, we are going to printf here, printf percent d remainder. Okay, remainder we are going to print here, remainder in the first step, that is equal to percent d rem. Okay, so now if you run here, suppose we take here 8 and 18, so what is your remainder is what? 2. If we divide 18 by 8, then it is what? Remainder is 8 times 2 is 16, and 18 minus 16 is what? 2. So remainder is equal to what? 2. So this is what? Remainder. We are going to calculate the remainder. Next, while the remainder is not equal to 0, while remainder is not equal to 0, we are going to interchange the numerator is what? Denominator, and denominator is remainder, and remainder is what? Remainder is equal to numerator modulo denominator. Okay, and we close while loop. Okay, now finally we are going to print f GCD is equal to percent d. What is GCD? Our denominator, last non-zero denominator. And what is LCM here? So to find LCM is equal to A star B divided by GCD. this divided by GCD. If we divide it by GCD, then we get LCM, and finally we are going to printf here. Printf this LCM is equal to list common multiple is equal to %d LCM. Okay, bracket completed. We want new line here. We have to write here new line, one more new line here, also new line, and okay, one more new line. So now if we compile here, zero error. Now if we run, so if we take here 12 and 18, so GCD is wrong. Okay, so what is mistake here? Okay, here is well, there is one mistake here. Instead of percent d, we print only percent sign, so it is percent d. Now if you run, say here 12 and 18, the GCD is what, 6, and LCM is 0. So there is one more mistake. What is LCM? LCM is what, a star b divided by GCD. So instead of GCD, okay, we want to store GCD. GCD is equal to denominator, and then we are going to print here GCD instead of GCD. Now if you run here, see here 12 and 18, the GCD is 6 and their LCM is what, 36. If we enter one more times, see here, say last time it is 12 and 32, so their GCD is what, 4 and LCM is 96. If we run one more time, say 6 and 8, their GCD is 2 and LCM is 24. If we run one more time, say 5 and 10, so their GCD is 5 and LCM is what, 10. So this is the program of to find a GCD and LCM. In the here if statement, we use to assign the numerator to largest value and denominator to smallest value, and then then here we find the remainder value by dividing numerator by denominator, and then we use the loop. Okay, and then finally we print GCD and LCM. So thank you.